Welcome back. This video is part 2 of a 9-part series on completing the square. In this video we will discuss how to use FOIL, how to distribute squared binomials, and how to compare the result to the perfect square pattern that we'll use later in the series. I suggest that as you watch this video you take notes, get a pencil and some paper, and let's get started. A perfect square is a number that can be written as a square. For example, 25 can be written as 5 squared. 49 can be written as 7 squared, and 100 can be written as 10 squared. There's a similar pattern for quadratic functions, although it looks a lot different. Instead of a single number, like 25, there are 3 terms, and instead of 5 squared, there's a squared binomial. In this video, we will use specific cases to check the validity of this pattern. First, let's see if we can get a better understanding of this pattern using a concrete numeric value. Let's pick the value b equals 8. According to this pattern, we need values for b and b over 2. b over 2 equals 8 divided by 2 equals 4. We use this pattern and replace b with 8 and b over 2 with 4. 4 squared is 16, and so we get x squared plus 8x plus 16 equals, in parentheses, x plus 4 squared. Let's try some examples of perfect squared binomials to get a better understanding of this pattern. Say we have x plus 3 squared. Squaring a quantity means that you multiply it by itself, so x plus 3 squared is x plus 3 times x plus 3. A technique known as FOIL is a common method to help with this distribution. FOIL is an acronym for first, outside, inside, and last. We multiply the first terms, x times x, and get x squared. Then the outside terms, x times 3, when written with the number or coefficient first, is 3x. Then the inside, 3 times x, is 3x. And the last term, 3 times 3, which gives 9. The two middle terms, called the cross terms because they cross the number and the variable, can be combined to yield 6x. We get x squared plus 6x plus 9. Let's compare this to the perfect square pattern introduced earlier. First, let's identify the value of b. b is 6. Then identify b over 2, which is 6 over 2, which equals 3. Finally, b over 2 squared is 3 squared, which is 9. So this result matches the pattern. Notice how that middle coefficient, in this case 6, is always twice the constant in the perfect square, 3. This is because adding the cross terms from the previous page always doubles this value. Now let's try that again, but this time use a negative number. X minus 5 squared is x minus 5 times x minus 5. Using FOIL, x times x is x squared, x times negative 5 is minus 5x, negative 5 times x is minus 5x, and negative 5 times negative 5 is negative 5 squared. The two cross terms combine. Minus 5x minus 5x gives minus 10x, and negative 5 squared is positive 25. When a negative number is multiplied by a negative number, the result is always positive. We get x minus 5 squared is equal to x squared minus 10x plus 25. Let's again check to see if this matches our perfect square pattern. First, let's rewrite x minus 5 as x plus negative 5. Subtracting a number is the same as adding the negative value. For similar reasons, let's write minus 10x as plus negative 10. And the final change is to write 25 as negative 5 squared. These changes will make it easier to compare to our pattern. b equals negative 10, b over 2 is negative 10 over 2, which is negative 5. And the last term is negative 5 squared. So again, our result is consistent with our pattern. Although we didn't derive this pattern, maybe you could see how a mathematician performing FOIL on many different combinations of numbers could have come up with this pattern by induction. Let's say that you aren't given this pattern, for example. Let's say that your instructor does not give this equation to you during an exam. Understanding FOIL can help you remember or even derive this relationship. What if you are in the situation where you can't quite remember which term should be b and which term should be b over 2. By performing FOIL on an example, you can identify which of these possibilities is correct. Now try some on your own. Please pause the video and try these out. X plus 6 squared is x plus 6 times x plus 6. Using FOIL, x times x is x squared, x times 6 is 6x, 6 times x is 6x, and 6 times 6 is 6 squared. Combining the cross terms and making 6 squared 36, we get x squared plus 12x plus 36. Similarly, x minus 7 squared is x minus 7 times x minus 7. Using FOIL, x times x is x squared, x times negative 7 is negative 7x, negative 7 times x is negative 7x, and negative 7 times negative 7 is negative 7 squared. Combining the cross terms and making negative 7 squared positive 49, we get x squared minus 14x plus 49. You can make your own problems to practice by coming up with values that you can add or subtract from x. That concludes this lesson. If you liked it, then click the like button below. In the next lesson, we'll use this pattern to complete the square. We'll have equations in the form x squared plus 12x, and we'll use this pattern to determine what we need to add in order to complete the square. See you in the next video.